Atoms are so small that they cannot be observed directly and their mass cannot be measured with any scale. For this reason, scientists use the relative mass scale to determine the mass of atoms. According to this scale, the mass of atoms is measured with a weight whose mass is 1/12 of the mass of carbon-12 isotope. This weight is called atomic mass unit. If we consider the mass of a carbon-12 isotope equal to the number 12, then we divide this number into 12 equal parts. Each part is called 1 AMU. In this way, a scale is obtained that can be used to measure the mass of all atoms and even subatomic particles. In this scale, the mass of proton and neutron is approximately 1 AMU and the mass of electron is 1 divided by 2000 AMU. Note: the number written in the periodic table as the mass of elements is the average atomic mass, which is an average of the mass of the different isotopes of an element in proportion to their abundance in nature. With this description, the mass of lithium atom can be considered as 6.94 AMU because there is 2 isotopes of lithium in nature, which their abundance in nature is shown below, and we can calculate its average atomic mass in this way. Scientists use a device called a mass spectrometer to measure the mass of atoms very accurately, so that the data shows that the mass of each hydrogen atom, which is about 1 AMU, is about 1.66 multiplied by 10 to 24 grams. Now let's calculate how many atoms are in a sample of 1 gram of hydrogen. We do this operation for carbon as well. Pay attention that we said the mass of each neutron and proton is approximately equal to 1 AMU, and the mass of the electron is very small. So carbon-12, which has 6 neutrons and 6 protons, has a mass of 12 AMU. We remember the mass of 1 AMU from the previous example. Now we count the number of carbon atoms in a 12-gram sample of carbon. Do this operation for each element and you will get this number. This number is called Avogadro's number and is represented by Na. This amount of each element is called 1 mole of that element, and the mass of 1 mole of particles in grams is called its molar mass. Amedeo Avogadro, the famous Italian chemist, in whose honor the number of particles in 1 mole of matter, Avogadro's number, is named. So, for example, the molar mass of iron is 58.5 grams. That is, 1 mole of iron has a mass of 58.5 grams. This number is the average atomic mass shown in the periodic table. Question: how many grams is 5 moles of aluminum? We know that the numerical value of the molar mass of an element is equal to the average atomic mass of that element shown in the periodic table. So the molar mass of aluminum is approximately equal to 27 grams, and we will have